Okay, recapping problem number one, we find that it looks like that. We take the integral, we get the right answer. Moving on to problem number 12. Now, I'm sure that the audio that came first would be perfectly okay there. All right, so we've got y is equal to x squared, x is equal to 1, x is equal to 2, y is equal to 1, and revolving about y is equal to 1. So we're not revolving around the x-axis or the y-axis, but we're revolving around y equals 1. Okay, so now we got to have a better than normal picture. So I've got y is equal to x squared, looks like this. Okay, x is equal to 1 is there. X is equal to 2 is here. And this guy, we're going to be evolving around y is equal to 1. Change colors. Y equals 1. So we're revolving that piece there around y is equal to 1. Okay, so we have the bigger slice, which is that, and we're going to have to subtract that from it in order to get that answer. Okay, is that clear what we're doing? So I'm going to find the volume of the big guy first. So I'm going to take volume pi integral 1 to 2 of x squared dx. And then I'm going to subtract from that the little guy, 1 to 2, and this is going to be 1 dx. So basically, yeah, that's what we're going to do. So that's how I'm going to set up the problem. And now I'm going to say that I've got pi times x cubed over 3 between 1 and 2 minus pi x between 1 and 2. Alright, so I put in the 2, and that's I got pi. I've got 8 thirds minus 1/3 minus pi times 2 minus 1. Did I just blow it really bad? Yeah, I did. Let's see. How am I gonna recoup from that anyway? Let's do one of these things. So we get down to undo, 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 undo. Okay, so back to this is squared. This is squared, right? Because the formula says, where's the formula? There it is. Says pi integral the function squared dx. Did we square it last time? Yeah, we squared it last time. Yeah. So it's just this time that we're hosed. Alright, back to what I'm doing. So the volume's going to be pi integral 1 to 2 of x to the 4th dx minus pi integral 1 to 2 of the same 1 dx. Alright, well that should be okay then. Pi x to the 5th over 5 evaluated at 1 and 2 minus pi x evaluated at 1 and 2 2 to the 5th. So that'd be pi 32 over 5 minus 1 over 5 minus pi times 2 minus 1. Okay, so I've got pi 31 over 5 minus pi. All right, so that would be so this would be 5 over pi. 5 minus 31 is 26 over 5. 26 over 5 pi. And what is it, 12? It's not there. That is correct. All right. So it's an even problem. It's not in the back of the book. Okay, so we're going to claim that we got 2 right. All right, and next we're going to do 24. Okay, you got enough of that? Number 24. And we've got x is equal to 2y squared plus 1. And we've got x is equal to 4 minus y squared. And we're going to rotate this about the y-axis. All right, so when x is 0, y is nothing. When x is 1, y is nothing. When x is minus 1, y is nothing. All right, when y is 0, x is 1. All right, so when y is 2, when y is 1, when y is plus or minus 1, then this guy is going to be 3. So I got something that looks like that. And then the other curve, so we're going to look at that curve next. When y is 0, x is 4. When y is 1, x is 3. So I'm hitting myself right there, and I'm coming like that. So I'm taking this shape that's in here, and I'm going to rotate it around the y-axis. Yeah, that's what I'm going to do. Okay. So obviously I'm going from minus 1 to 1. And I'm going to take this volume that's made by the purple guy and subtract the volume made by the black guy. Okay, so I'm going to subtract that amount from the total purple amount, which would be everything. Okay, so that's the plan. Okay, so volume is equal to pi integral minus 1 to 1 of 4 minus y squared dy minus pi integral minus 1 to 1 2y squared plus 1 squared dy. Okay, so that's how I'm gonna set up the problem, and trusting to luck. So v is going to be pi integral minus 1 to 1 of 16 minus 8y squared plus y to the 4th dy minus pi integral minus 1 to 1 4 y to the fourth plus 4y squared plus 1 dy. Alright, so volumes equal pi 16y minus 8 over 3y cubed plus y to the fifth over 5 minus 1 to 1 minus pi 4 fifths y to the fifth minus 4 thirds plus 4 thirds y cubed plus y. Evaluated at minus 1 to 1. Okay, so we're almost out of room. Volume's going to be pi. Okay, so I'm going to have a 16. I'm going to have a minus 8 thirds. I'm going to have a plus 1 over 5. I'm going to have minus a minus 16 plus 8 over 3 minus 1 over 5 minus pi times, I put in a 1, 4 over 5, 4 over 3 plus 1 minus, I'm putting in a minus guy, so I got minus 4 over 5 minus 4 over 3 minus 1. All right, at that point, I don't have my calculator, so but I just put it in my calculator if I was going to do it. So I got pi. Okay, I've got 1/5 minus a minus. So I got 2/5. All right, so I got 32 plus 16 thirds plus 2/5 minus pi times 8/5 plus 8 thirds plus 2. Alright, so I got pi times, okay, here 2 plus 8 is 5. So there's a 2, but one's plus and one's minus. Oh, bummer. Alright, so I got 30 minus 2, so I got 30. I got 16 minus 8, so that'd be 8 thirds. I've got 2/5 minus 8/5, so that'd be minus 6/5 times pi. And anybody got that answer yet? Alright, well, I guess I got to do it then. What's 15 times 30? 0, 5, 1 to carry. So that'd be 450 plus 40 minus 18 over 30 pi. 490, 480, 472, 472 over 30 pi. Does 3 go into there? No, 3 doesn't go into there. 5 doesn't go into there. But 2 does. So 2 does go into there. 236 over 15 pi. And that's what I have. Again, I'm doing it without a calculator, which is not a professional thing to be doing. Okay, moving on to section 25.3, and now we're going to do shells. Okay, so what we're going to do is I've got some curve, boom, and I'm going to take some shell and I'm going to rotate around that shell, and then I'm going to take another shell, I'm going to rotate it around. So I'm not doing discs, I'm moving shells around. I got some dx, that's my thickness. I've got some radius, so I got some radius r sitting there, and then I've got some height that's that high. So I'm going to go volume is equal to 2 pi integral a to b, which we'll have to figure out what those guys are later, x, which is my radius, times the height, f of x, times d of x, which is my thickness. So I'm going to go radius, height, thickness. And then we're rotating this about the y-axis. When I do dx, I'm rotating it around the y-axis. Okay, or I can go volume is equal to 2 pi integral a to b. Why 2 pi? A to b, radius, height, thickness, and now I'm rotating about the x-axis. So the 2 pi r, so 2 pi r is the circumference of a circle. Okay, so I got 2 pi r, the circumference of a circle. I'm multiplying that times the height h and some thickness dx to find the shell that I'm forming by doing this particular operation. Okay, that being the case, we're going to look at problem number 1. And with a little bit of luck, this is the same problem number 1 as in the last section, so I should get the same answer. That would be the ideal thing, and it's not. Stupid author, anyway. So problem number 1, I have y is equal to 4x squared. I have x is 0, I have y is 4, and I'm rotating about the y-axis. Alright, so I'm going to draw a picture. 4x squared. So when I'm at 1, I'm at 4. Okay, so I got something that's looking like that. X is equal to 0 is there. Y is equal to 4 is up here. About the y-axis. Okay, so I'm doing shells. Am I taking the top part and I'm sending it around the y-axis, or am I taking the bottom part down here and sending it around the y-axis? Which one am I doing? Okay, so I have to be x is equal to 0 straight up and down, right? So x is equal to 0 is that. X is equal to 0, that. So I'm taking this spot here and I'm rotating it around the y-axis. Okay, so I'm going to go volume 2 pi, integral is going to go 0 to 4, y is my radius, 0 to 4, no, it's x. and I'm going 0 to 1. 0 to 1, x, 4x squared, dx. So I'm making shells in here. My radius is x. My height is not 4x squared. My height is not 4x squared. My height is 4 minus 4x squared. Okay, because at 0 my height is 4, but at 1 my height is 0 dx. Okay, so now we got the problem set up. Volume, what am I doing in green? 2 pi 0 to 1 4x minus 4x cubed dx 2 pi times 2x squared minus x to the 4th evaluated at 0 and 1. 2 pi, I put in a 1, 2 minus 1 is 1, right? Put in a 0, I get a 0. Is the answer 2 pi in the back of the book? Huh? 2 pi. 2 pi is what the back of the book says. I don't believe it. Darn. That just makes my whole day. Number 13. Okay, I've got x is equal to y cubed, y is equal to 1, x is equal to 0, and I'm going to go about y is equal to 2. Okay, so that's what I'm going to do. I'm going to draw a picture of this. X is equal to y cubed. So when y is 1, x is 1. When y is minus 1, x is minus 1. Okay, so I got a curve that looks like that. And then I've got x, y, yellow. Then I got y is equal to 1. Okay, so there's y is equal to 1. And then I got another curve, x is equal to 0. There's x is equal to 0. Okay, and I'm going to rotate this around. Y is equal to 2. So there's 2. So it looks like I'm rotating that right there around y is equal to 2, so that would be like that. Alright, so that's like I'm rotating it around the x-axis, only I'm not. Okay, so what I'm going to do is I'm going to do the same thing again. I'm going to find all of this, the whole thing, and then subtract the bottom thing. So that's my plan. So v is equal to 2 pi integral 0 to 1 of x, not x, yeah, x. No, we're rotating around y is equal to 2, which is really the x-axis, so that's got to be y. We're rotating it around the x-axis. Alright, so we're really rotating it around the X now. We're about Y equal 2. So that's up here. We're rotating it that away. So if I get this and I subtract that, then that would be the same if I did that. Okay, so, okay, I got it. 0 to 1, Y. That's not 0 to 1, Y, though. I'm going to go 0 to 2, Y. And then the whole thing is going to be, oh, bummer. I'm going to go and make it yeah, I agree with Eric. Okay, now got this little bit. I'm rotating around that guy. Okay, we're going to go 1 to 2. 1 to 2 X, which is my radius. Now, what is my radius? My radius is going that way. And then this is going to be my height. My radius. What's my radius going to be? I don't know. Okay. Let's make sure we're doing what we think. We've got this. We've got at Y is 1. X is 0. That's what I'm rotating. I'm rotating it around this guy up here. Now if I get the whole guy and subtract that part, that would be good. But I'm doing this with shells. Okay, so I'm going to take that guy. I'm going to go 1 to 2. Okay, so I'm going to go 1 to 2 for my radius. This guy is going to go Y cubed. Function of Y. Cube root of X dx. Alright, that's what I'm going with. If I get it wrong, we're moving on to the next one. Okay, so integral 1 to 2 of x to the 4 thirds dx, 2 pi x to the 7 thirds divided by 7 thirds evaluated to the 1. 2 pi, I put a 2 in there. 2 to the 7 thirds. Okay, so 3 halves. 2 to the 7 thirds? You gotta be kidding me. 2 to the 7/3. That's going to be 2 the square root of 2, right? 2 the square root of 2 minus, I put in a 1, 3 over 7. Alright, so I got 3/7 times 3/7. Okay, so I can bring that out. So I can have 6 pi over 7 times 2 the square root of 2 minus 1. This is number 13 of, they have 5 pi over 6. That doesn't look like 5 pi over 6 to me. So we'll mark it wrong and move on. And last problem. 24, no, not 24, 20. Much better problem because you don't know if I got it right or not. 20. Y is equal to x minus 2 squared. Y is 0, rotated on the y-axis. Alright, so what does this curve look like? When x is 0, y is going to be 4. Okay. Oh, yeah. Where's Maple? There's Maple. About time. Should have gotten here sooner. Graph Builder. Y equals, so y equals x times x minus 2 squared. Except, okay, plot it. Okay, so that's what the curve looks like. And I want to go y is equal to 0. So that means I'm going to go 0 to 2. Because obviously when I cross 2, I'm going to be at 0. So I'm at 0 at 0, and I'm 0 at 2. Okay, that's good. Okay, so back to here. So basically I have something that looks like that, 2, 0. And I'm going to rotate it that way around the y-axis. Okay, so volume is going to be 2 pi integral 0 to 2. The radius is x. The height is x minus 2 squared dx. Alright, now why couldn't I figure that out without Maple? 2 pi 0 to 2 x squared minus 4x plus 4 dx. 2 pi 0 to 2 x to the 4th minus 4x cubed plus 4x squared dx. 2 pi x to the 5th over 5 minus x to the 4th plus 4x cubed over 3, evaluated at 0 and 2. When I put in the 0, that's going to be good because it's going to be always 0. I say I'm going to have 2 pi 32 over 5 minus 16 plus, what's 8 times 4? 32? 32 over 3. Oh, bummer. Common denominator is 15. 2 pi, 3 times that, 96 minus something plus 5 times this, 155 over 15. And then what's 15 times 16? 0, 3, 8, 6, 1, 240. All right. 2 pi. So I got 240 minus 150 and 155. 5, 9 from 5 from 3 is 8. And that's going to be a minus number. I'm going to add 96, which is going to be 11 over 15. So final answer, 22 pi over 15. Is this an even or odd one? This is an even one, so we're not going to look in the back of the book. Excellent. Moving on to section 25.4. 25.4 is center of mass. And the center of mass in the y direction is going to be summation mass times x divided by summation mass. And in the y direction, it's going to be summation mass times y divided by summation mass. And that's all there is. There is no more unless I have three-dimensional problems. Okay, so that's all there is. Do you need more than that? For those that are in Physics 1, you've already worked these problems, right? And number 1 says, I've got at minus 5, I've got a mass of 3. And at 3, I've got a mass of 7. And at 6, I've got a mass of 4. All right, so the center of mass is going to be 3 times minus 5 plus 3 times 7 plus 4 times 6 divided by 3 plus 7 plus 4. Okay, so minus 15 plus 21 plus 24 divided by 24. That's 6, right? 6, so that, 14? Alright, so I've got 6, I got 30. 30 divided by 4, where? Who? Did I do something wrong?
No.
So is 15 over 7. So the center of mass is at 15 over 7. All right, look in the back of the book real quick. 15 over 7 is correct. Lucky. Now, if I had my calculator, it would have been much better. But I don't, so. All right, next one, number 14. Because you already did it in physics, right? And it's not section 23.5, which makes you do it with integrals. Okay, so number 14. A straight road connects Leadville, Brandenburg, Princeton, and Four Oaks. The distance between Leadburg and Brandenburg is that to Princeton is that, and to Four Oaks is that. Where is the best place to locate a hospital to serve these four communities? Okay, so a straight road. Okay, so there's my straight road. Connects. There's Louisville, 1750. The distance from Louisville to Bramberg is 4 miles. So I got 4 miles there, and I'm at Bramberg, population 2,800. Between Bramberg and to Princeton, 10 miles. There's Princeton. Princeton has a population of 970. And we have 13 miles to Four Oaks. Four Oaks has a population of 4,800. All right. So I am going to pick this to be 0. Okay. And then I'm going to find the best place to put my hospital. Okay, so I'm going to have 0 times 1750 plus 4 times 2800 plus 14 times 970 plus 27 times 480 divided by 1750. Nope, it's only 480 plus. That'll teach you not to be having your book open to the right page. You know better than to listen to the instructor. Everybody in the whole room knows better than that. Huh? Everything's fine? Yeah, everybody knows that I can't be trusted when I open my mouth. Okay, so 1750 plus 2800 plus 970 plus 480 equals. So I have 6,000 on the bottom. And on the top, where's my clear everything? I have 4 times 2800 plus 14 times 970 plus 27 times 480 37740. And I'm going to divide that by 6,000. 6.29 miles. 6.29 miles from Louisville. Is it Louisville? Leadville. Leadville. All right. So we look at the map. That's about right here. Yeah, that's probably good. Yeah. Well, not. Yeah. Pretty much. Yeah.
Well, you've got to understand that people do this.
Yeah. Actually, the right answer is wherever my farm is. Right, and you're going to pay me top dollar for it. Or it's wherever Joel's farm is, because they're going to use eminent domain and take it for 10 cents on the dollar.
Oh, yeah.
Yeah. So forget about my farm. I'm not going to do it there. All right. So last one, 21. So I got to get 21 right because 21 is in the back of the book. Where is a mass? There is a mass, 15, at there, a mass at there, a mass at there. Find what mass should be placed there so that there is the center of mass. Okay, so we read the problem. That's about all we did. So I got 4 minus 5 minus 3. I got 16 at minus 4, 3. I've got 12 at 6 minus 4. I'm looking at the wrong problem.
Correct.
When were you guys going to tell me that?
We were discussing.
All right, problem number 21. I got 15 at 10, 3. I got 25 at minus 6 minus 1. I got 40 at 8 minus 2. Find the mass. Okay, so I want M at minus 5 minus 3 such that the center of mass is at minus 1 minus 2. Okay, so that's what I want to do. Now, I can't even see the whole problem at the same time. So, minus 1, the center of mass in the x direction, has to equal 15 times 10 plus 25 times minus 6 plus 40 times 8 plus m times minus 5 divided by 15 plus 25 plus 40 plus m. Okay, so I got minus 15 minus 25 minus 40 minus m is equal to 150 minus 150 plus 320 minus 5m. Okay, so I got 40, 50, 60, 70, 80. Is that what I got? 80? Minus 80 minus m is equal to 320 minus 5m. Okay, so I got 4m equals 400. M is equal to 100. Check the back of the book. Number 21. 100. Huh, lucky guess. I could have.
Do that the same for
Yeah, you
Y.
could have done it for Y. Yeah, I could have done the same thing for Y. I would have ended up with the same answer. Yeah. And in fact, I probably should go back and check it for Y before I say I'm correct. All right. So next time we're here, we're in chapter 19, which has to do with mean, median, mode. How do you calculate your final grade in the class, and why did the instructor give you an A when you clearly deserved a D? That's what chapter 19 is about. Control Alt